All right, next set of problems. We got I to the 49th. We got to perform the indicated operation, write the result in a plus bi form. Now, anytime we have something with a big exponent like this, I to the 49th, I to the 123rd, it doesn't matter what it is. We have to remember that I is equal to I. We have to remember that I squared equals -1. We have to remember that I cubed is equal to -I. And we have to remember that I to the 4th is equal to 1. So when we do something like I to the 49th, we'll write it down over here, we have to break this up into something with a multiple of 4 and then what's left over. So knowing 48 is a multiple of 4, I'm going to write it as I to the 48th times I to the 1st. And the reason I do that is because 48 plus 1, using our exponent rules, gives us I to the 49th. But also, I know that I to the 48th is just 1, because 48 is a multiple of 4. With that being said, it makes it really easy, because now I have 1 times I, which is just I. If I were to do another problem like, say, I to the 39th, okay, I could break this up into I to the 36th, because 36 is a multiple of 4, times I cubed. Well, I to the 36th is just 1. I cubed is actually -I, and so 1 times -I is -I. And so that's how we break up imaginary numbers like with really big exponents. The next problem, we need to FOIL. But before we do anything, when we see square roots with these negative numbers inside of them, we need to get that out. Get the I out, as I say in class. So when I see this, I'm going to write -2 minus I radical 2. And then square root of 8, we can break that down. That's 4 and 2, so it's 2 radical 2. And then plus I radical 2. All right? So I've just simplified this radical, and this radical. This one is real, these two are imaginary, but that's okay. Now we need to FOIL. So square root of 2 times 2 radical 2. Well, that's going to be 2, and it's actually going to be the square root of 4, which is also 2. All right? When I distribute to the next one, I'm going to get plus I times square root of 2 times the square root of 2, which is 2. In the bottom here, I'm going to get -2I, and then square root of 2 times the square root of 2, which is 2. And then the last one is going to be -I squared, and then square root of 2 times the square root of 2, which is 2. So that's what we get. Now, we need to kind of cancel some things out and take a look at some things and write it a little neater. First off, we got the I squared. That's going to make that a positive 1. -1 is positive 1. So that's going to just become 2. And let's write out what we have. What's 2 times 2? 4. And then we got plus 2I, and then minus 4I, because 2 times 2 is 4. And then this is plus 2. Now combining the two real parts, 4 plus 2, I get 6. Combining the two imaginary parts, I get -2I. And that right there is our solution in a plus bi form. All right? Next one, find all real and complex zeros of this nasty, nasty polynomial. P of x equals x cubed minus x squared minus 4x minus 6. So one of the first things that I'd want to do is I'd want to look at the graph. And when I look at the graph, I notice that 3 is a 0. And that's, you know, kind of the way that we're doing it. If you wanted to, you could find the rational roots here of p over q, possible rational roots, and plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Do synthetic division until you get a 0. But if you have a graphing calculator, I mean, what's the point? You can just look at the graph and find one of the zeros. When we do that, we know that 3 is a 0. We know that x minus 3 is a factor based off of the rational, or no, the factor theorem. Whew. All right, so let's write that again. All right, so x minus 3 is a factor. So when I write this out, I can write it out as x minus 3 times something. Well, to figure out what this something is, we need to do division, because if I take this and divide it by this, this will be what I get when I divide it. All right? We've used the example in class of 12 divided by 2 is 6. So I know 2 times 6 is 12. So let's do synthetic division. We got 3 here, 1, -1, -4, -6. Skip a line, draw a line. Bring down the 1. 3 times 1 is 3. -1 plus 3 is 2. 3 times 2 is 6. -4 plus 6 is 2. 3 times 2 is 6 again. And then we get 0 as a remainder. 0 as a remainder is good. Alright, we can even bring over our buddy here just to make sure. Donuts. Alright, so that's a good thing. Now, when we do this, alright, we've divided by x minus 3, so now we know that x squared plus 2x plus 2 is our quadratic that's left over. The trick to this is, can we simplify this? Can we factor this to get zeros? Well, are there two numbers that multiply together to give us 2 and add together to give us 2? Well, 2 times 1 is 2, but that adds together to give us 3. And then -1 and -2, that gives us -3, so no. So this quadratic we need to solve on our own. And if you can't factor a quadratic, what do we need to do? Quadratic formula. Alright? So we're going to say x squared plus 2x plus 2 equals 0. So now we got to say, alright, quadratic formula. For those of you that don't know, negative b plus or minus square root b squared minus 4ac all over 2a. If you have Mr. Clark, he'll race you. If you have Mr. Rawls, he'll sing it for you. Alright, -2 plus or minus the square root of 2 squared minus 4 times 1 times 2 all over 2 times 2. No, 2 times 1, sorry. -2 plus or minus the square root of 4 and -8, that's -4 all over 2. Then we got -2 plus or minus square root of -4 is 2i all over 2. And the last thing we want to do is put this in a plus bi form, which is going to be -1 plus or minus I. So here's our 2 of our zeros. Here's our third 0. Because it's a cubic polynomial, we know it's going to have 3 zeros. So we're going to say x equals 3 and -1 plus or minus I. Make sure that you simplify that last one, and those are your 3 zeros. Alright, check on back for the last part, and we'll do the last 2 problems.